Alright, that topic 15 review, we finally made it to the word problems. If you're in Mr. Hook's class, these may be a little bit different. I went back in and tried to make these numbers a little bit more friendly, just because we're intending you to leave these things in log form to figure them out when you can, just with mental math. Okay, so I went back in and made these a little bit more friendly. We have some acidophilus culture containing 150 bacteria that doubles in population every hour. Okay, 150 doubles every hour. Key 3 parts. We write a function representing that population for every hour that passes. Okay. We have those specialty equations that apply to compound interest and continuously compounded interest. Okay, and those come from the parent function, just y equals a b to the x. Okay, we don't really have a specialty situation here. We just have some exponential growth. So y is just going to represent the bacterial population. Okay. Starts at 150. Okay, a is always your starting point. B is the growth rate. Okay. How does it grow? It doubles. How do you double a number? You multiply it by 2. And then we double every hour. Okay, so I'm going to make that my x is the number of hours. Okay, so it's and another way of saying that is that's the number of times we double. Okay, so there's my equation that will give me the number of bacteria. And then it says predict how many will be there after 6 hours. Alright, so which one of my variables was hours? It was the x, so that's where I put the 6. And now you're thinking, I don't have a calculator. That's okay. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. How many 2's is that? 1, 2, 3, 4, 5, 6. That's 2 to the 6. Now I need to multiply it by 150. If you want to break out this right here, you can. You can multiply like that. Haven't done that in a while maybe, but the way I would do it is say 64 times 100 is 6,400. And then times 50 would be half of that, so that would be 3,200. And so this would be 9,600. So that equals 9,600 bacteria. No calculator required. Just stretching the brain muscles a little bit there. Now we have to determine how long it would take the number to reach 30,000. And that is a lot more brain power. So maybe we'll see what we get here. So 30,000 is the target. Okay, that's what we want to end with. Not the starting amount, not the growth rate, not the number of hours. When it says how long, it's talking about time. That's the x variable. So that's what we're solving for. Equals 150 times 2 to the x. Okay. So what's the first step in solving this? You will divide by 150. And when you divide that by 150, you get 2,000. No, 200. Yeah, 200. One too many zeros. Okay, so we get 200 equals 2 to the x. Alright, now how do we get that x out of the exponent? We are going to switch it into log form. So that's a log of base 2. The base stays the base. The other 2 trade spots. So the x was with the 2, but when we switch into log form, now the 200 is going to be with the 2. It's equal to x. Okay, so 64 was 2 to the 6th. If we multiply by 2 again, we get 128. That's 2 to the 7th. And then if we multiply again, we get 256. It's 2 to the 8th. Okay, so somewhere between the 7th and the 8th hour, but we can just leave it as log base 2 of 200. That is the number of hours it's going to take to get to 30,000 bacteria.